Hello, how are you? Good day. Today I will be presenting to you another mathematical ideas. For now, we have direct variation of the form y equals k times x. We know that variation is a mathematical statement between variables or quantities. For now, we have variables x and y. It helps in the representation and description of any given set of data, like the common area of the polygons, or maybe, perhaps, the volume of a certain object. For instance, we have area of the square area, A equals S squared. So this is a common formula. The area really, as we know, depends on whatever value we put to S. So for that, S is related to area. And that is simply variation. Okay? The basic type of variation is referred as the direct variation of the form y equals k times x. Ky equals k times x can also be read as y varies directly as x. Okay? So y equals kx can be read as y equals or y varies directly as x. Or y is directly proportional to x. And the third one is y is proportional to x. Okay, go back to our direct variation of the form y equals k times x. Okay, the direct variation is the type of variation where the ratio of the two variables are held to be constant. Okay, for instance, okay, since the ratio is held constant, by applying the multiplication property of equality, we can actually multiply the equation both sides by 1 over x. So we have y equals k times x. By multiplication property of equality, we can multiply both sides by 1 over x. Then 1 over x. So simply 1 times y over x is y over x. So k times x times 1 divided by x, what is left? K. So y equals or y over x is equals to k. K is called as, since now we have the ratio as defined, the direct variation is a type of variation where the ratio is constant. If you have the same ratio so that is already direct variation. So k is called as constant of variation. Okay, another one. Say you have another statement. Say in particular you have particular example, you have a pair of x and y. Okay, the first pair x subscript 1 and y subscript 1. So out of the pattern or model, your direct variation now is y subscript 1 equals k times x subscript 1. Again, by multiplication property of equality, or simply by dividing both sides by x subscript 1. In order to get constant of variation, you can have x subscript 1 divided by x subscript 1. To the left, we have y subscript 1 over x subscript 1. So you have actually the constant of variation is y subscript 1 over x subscript 1. Okay, in the direct variation, if the ratio is actually the same, again that is a direct. So in conclusion, we have k should be constant because they are of the same value. From the ratio of generally you have the y over x and the same value of the ratio of y subscript 1 over x subscript 2. If you have another pair or another related values, as long as the ratio is constant or the same, you can say that the direct variation occurs. Say y subscript 2 over x subscript 2. This is the statement of a particular variation, specifically direct variation, if their constant ratio is the same or constant. Okay, I have here some examples. Okay, example or activity number 1. Write the equation for the statement m varies directly as n. So as we know, we can read the statement as in the previous statement I have. So m varies directly as n is simply first of making a relationship, you can first make m, then varies directly. Okay, varies directly is you will be using k as your constant of variation, then use n. So that's simple. Another example I have here. Example, if y varies directly as x and y is 15 when x equals 3, find y if x equals 5. Okay, again, if y varies directly as x and y is 15 when x equals 3, find y if x equals 15. Okay, first is you have to use our general model of the form or the pattern y equals k of x. In the statement, we are using x and y from the example because we have y and x. So it's easy. So what are the given? The given is, the first is y equals, this is the given. Y is 15 when x equals 3. Okay, what is required? The required value is if x is equal to 5, what is actually the value of our y? So first is, the first procedure for that is really to get the value of k or the constant of proportionality. First, we will be getting the value of k using these first two. So solving for k, we have as k to substitute, we will be using 3. So k times 3. If x is 3, then for y we will substitute 15. So you have 15 k 3. So by multiplication property of equality, or simply by dividing both sides by 3 over 3, so k now is what? 3 times 3 divided by 3 is k. So what is left is k. 15 divided by 3 is 5. So now our constant of variation is k equals 15. Go back to our model. We will now have y equals, we will now use, instead of k, we will be using 5 x. Okay, this is where we can get the value of y when x equals to 5. So what is the value of y when x is equal to 5? So simply y equals 5 times, what is y when x equals to 5? So 5 times 5. Okay, so our y equals to 5 times 5, 25. So as you can see, x is 5, then directly y equals to 25. So if you make a table like this, you can detect that we have a direct variation y.